Hello learners, welcome to today's lesson. This is Form 4 Mathematics under Differentiation and Integration. But today we are going to look at differentiation and its applications. But before we look at that, this is a topic that extends from Form 2 under gradients and equations of straight lines. And in Form 2, we said that the gradient, the equation of a straight line is usually in the form of y is equals to mx plus c, where m is the gradient and c is the y-intercept. We also looked at how one can find the gradient of a straight line, and we said the gradient of a straight line is given by the change in y coordinates over the change in x coordinates. Another thing we said is that in case you are dealing with perpendicular lines, we said two lines are said to be perpendicular if the product of their gradients is equal to -1. That is, if the gradient of line 1 is m1 and the gradient of line 2 is m2, if you take their product, it must always give you -1. Another thing we said is on parallel lines, and we said if two lines are parallel, then their gradients must be equal, i.e. m1 must be equal to m2. The last thing we did again under this topic is that we said if you have been given an equation that is y is equals to, for example, 4x plus 10, and you are told to find the angle that this line makes with the x-axis, we said, assuming we do a sketch of this line here, and the line we have is y is equals to 4x plus 10, and you want to find the angle this line makes with the x-axis, then that angle is going to be given angle theta. Then we say the tan of the angle theta is always usually equal to the gradient, and the gradient of that line is 4. And if you want the size of theta itself, we are going to take the tan inverse of the gradient for us to be able to get the angle in question. Going back to differentiation, this topic will not deal with the gradients of straight lines, but the gradients of curves. Differentiation by definition means it is the process of getting the gradient function of a curve. If we have, for example, our Cartesian plane here, and we have a curve like this, and you want to find the gradient of this curve, you can only find the gradient of a curve at a point, and that point is what we call a tangent. A tangent is a line that touches the curve at one point, and you can only get the gradient at that particular point. So if you need to find the gradient of this curve, using the normal way, you have to draw as many tangents as possible, then you get their gradients. From there, you add all the gradients for you to be able to get the gradient of this single curve. But what if this curve is in the function y is equals, for example, to x power 3, and you want to find the gradient of this curve? So for us to get the gradient of a curve is usually given by the change in y over the change in x. So under differentiation, we say to get the differentiation or the gradient of a curve using differentiation, this power here multiplies behind such that we are going to have 3, then we multiply by x cubed, then now this power of x is going to reduce by 1, and we are going to have 3x, then 3 minus 1, we are going to have 3x squared. If we can take another example, for example, if you have y is equals to, let's say you have 4x cubed plus 2x squared plus 8x plus 5, and you want to find the gradient function of this curve here. So to get the gradient, we know the gradient is usually given by the change in y over the change in x. What we are going to do now, we differentiate each function separately. These 3 will multiply here so that we have 12. Then you go and less the power of x by 1. We are going to have 3 times 4, which is 12x. Then if you less 1 from the power here, we are going to have squared. Then from here we have 2. It multiplies back here so that we are going to have 2 times 2, which is 4x. Then if we less the power of x by 1, we are going to have simply 4x, or 4x raised to power 1. Then plus, if we have to differentiate this one here, it means the power of x is 1. 1 times 8 will be 8. Then if we less by 1, we know any number raised to 0 is 1. And then 1 times 8 is going to give us 8. And that is how this one is done. We are not going to differentiate 5 because 5 does not have x. If I can take the last example here so that we can all know how differentiation is done. What if I take the third example where y is equals to, let me say 3x power 4 minus 2x power 2 plus, for example, 9x plus, let me say like 8. We know to get the gradient function of this curve by differentiation, the gradient of anything is change in y over change in x, and this one is going to be equal to, under differentiation, the power is going to multiply here so that we have 4 times 3, it is going to give us 12. Then you go and less 1 from the power of x, we are going to have x power 3. Then we have minus 2 multiplies here so that we have 4. If you less 1 from the power of x, we are going to have x power 1, which is simply 4x. Then plus, if you want to differentiate 9x, this is the same as 9x raised to power 1. So 1 multiplies here so that we have 9x power 1. Then we less 1 from the power of x such that we have 9x power 0. And any number raised to 0 is actually 1. 1 times 9, we are going to have 9. And if you want to differentiate a number which does not have x, we have 8, but this 8 has a coefficient, for example, of x, but this x is here is raised by 0, such that if you take 0 here, you multiply by 8x power 0, then you less 1, it is going to give us 0 times 8x minus 1, and anything times 0 will give you a 0. Hence, we do not differentiate anything that does not have x. In summary, if you have been given a function in the form of y is equals to x power n, and you're supposed to find the gradient function, then our dy over dx must be equal to, we bring this power here so that we have n, x power n, then of course we less 1 from the power of x, and that is how we do differentiation. Now, let us take a question under differentiation so that we can learn on how to apply this knowledge on this topic. Let us go through this question under differentiation. A particle moves in a straight line in such a way that its distance s meters from a fixed point D after t seconds is given by, this is our distance or displacement, which is a third 3 power 3, that is t power 3 minus 2 over 2t squared plus 2t. You are required to find the position of the particle when it is momentarily at rest, then find the acceleration of this particle at this point, and finally you find the maximum or minimum velocity of the particle. So any question that might come from differentiation will automatically be in the form of displacement. It can also be a question on velocity, also a question on acceleration. It can also be a question in the form of y, and also it can be a question that deals with the change in y over change in x, which is the gradient function of that particular curve. From here, we have been given the displacement function, which represents distance, and we are supposed to calculate the position or the distance of the particle when it is momentarily at rest. When the particle is at rest, it means it has zero speed or zero velocity. We can say, let us take the solution for this and say, at rest, the body will always have what we call zero speed or zero velocity. If you have been given the displacement function and you want the velocity function, you are going to differentiate displacement for us to get velocity. If you need acceleration, differentiate velocity in that order. Therefore, our function we have is s is equals to a third t cubed minus 3 over 2 t squared plus 2t. So for us to get the velocity function, velocity is always equal to the change in displacement over the change in time. That is delta s over delta t, and this one is going to be equal, if you differentiate this first part, 3 multiplies here such that a third times 3 is 1, then you go and less 1 from the power of 3, that is the power of t, we are going to have t squared, minus these 2 multiplies back here so that 2 and 2 goes, so that we remain with 3t. If we less 1 from the power, it's going to be 3t power 1, which is the same as t, plus if you differentiate this term here, it is going to give you 2, because we have already said if we have 2t here, 2 is obviously raised to power 1. If you multiply it here, it will be 2. Then you less 1, it is going to be 2t power 0, and any number raised to 0 is 1. 1 times 2 will give you a 2. From there, we know when the particle is momentarily at rest, then the velocity is going to be equal to 0. So from there, you realize this is a quadratic function which is going to be solved using the methods we have already discussed, and I'm going to use what we call factorization to try and find the value of t. So if I take this expression here, we are going to have t squared minus 3t plus 2, which is equals to 0. We are going to get the product, we get the sum, and also the numbers. To get the product, we look at the coefficient of t squared, which is 1, times the constant 2 to give us 2. Then this is t, which is the same as x, and the coefficient of t is our sum, which is 3. So we need two numbers whose product is positive 2, and the same numbers will give us a sum of negative 3, and those two numbers are negative 1 and negative 2. From there, we go and use them to do the expansion. So we are going to start with t squared, then instead of this middle term, we use the numbers, which is the same as minus 1t or minus t minus 2t, which is equivalent to that is minus 2t, plus 2, and this is equal to 0. If we take the first two pairs, and factorize it, we are going to realize that t is common on both sides. So if we move t outside, we are going to remain with t minus 1 here. Then if you look at these two here, 2 is common into, we have t minus 1, and this is equal to 0. Then from there we have t minus 2 is equals to 0. T is going to be, if you take negative 2 to the other side, t is going to be 30 seconds. And then t minus 1, if we pick 1 from the brackets, it's going to be equal to 0. So our t, if we take negative 1 to the other side, we are going to get 1 second here. That means the particle is at rest between 1 second and 2 seconds. But the question reads, find the position of the particle when it is momentarily at rest. Position here refers to distance, and in this case, we are going to substitute our t values back to the displacement function for us to be able to get the position. So our s is going to be equal to a third t cubed minus 3 over 2t squared plus 2t. From there, we know at t is equals to 1 second, then our displacement is going to be equal to, this is a third, into t, which is 1 raised to power 3, minus 3 over 2 into t, which is 1, we raise it to power 2, plus 2 into t, which is 1. From here we know 1 power 3 is 1 times a third will be equal to a third. Then minus 1 squared is 1 times 2 over 3 will be 3 over 2. Then of course 1 times 2 will be equal to 2. From here, allow me to express this one as a fraction. Then from there we can be able to get the LCM. And the LCM of 3, 2 and 1 is 6. 3 goes to 6 2 times, then 2 times 1 will give us 2, minus 2 goes to 6 3 times, then 3 times minus 3 will give us minus 9, and of course 1 goes to 6 times, then 6 times 2 will give us 12. From there we know that we can do the addition first. 2 plus 12 is 14, then 14 minus 9, this one is going to give us 5 over 6, and that is. From there again, we need to get the position of this particle after 2 seconds. We need to get the position of this particle after 2 seconds. From here we know when time is actually 2 seconds or exactly 2 seconds, the position of this particle is going to be equal to, we have a third times t, and our t is going to be 2, but the 2 is cubed, minus we have 3 over 2 into t, and our t is actually 2, but the 2 is squared, plus we have 2 into the value of t, and the value of t is 2. From here we know 2 power 3 is 8. 8 times a third will give us 8 over 3. Then minus, we have 2 squared is 4. Then negative 2 over 3 times 4 will give us such that 2 goes to 4 2 times. Then 2 times 3 will give us minus 6, plus 2 times 2 is 4. From here we can express this as a mixed fraction such that 3 goes to 8 simply 2 times, then we remain with 2 over 3, then we can add 4 before we minus 6, and 2 plus 4 is 6, 6 minus 6 will give you 0, and therefore this one is going to remain as 2 over 3 meters, meaning when the particle is 2 seconds away, it should have covered what we call 2/3 meters. And that is the answer to the first part of the question, which is part A. Going to part B, Going to part B of the question. Going to part B of the question. We are supposed to find the acceleration of this particle at this point, meaning we find the acceleration of this particle at the time t is equals to 1 and t is equals to 2 seconds. That is part B of the question. So we are supposed to find what we call acceleration at t is equals to 1 second and t is equals to 2 seconds. But we know for us to get the acceleration, we need to get the acceleration by differentiating our velocity. And our velocity function is, we have already differentiated that, and we have our velocity function, and our velocity function is going to be equal to, and we know our velocity function was actually t squared minus 3t plus 2. But for us to get acceleration function, we have to differentiate the velocity. That is, dv over dt must give us acceleration. So we are again going to differentiate the velocity. That is, 2 is going to multiply here so that we have 2, then t squared. If we less it by 1, we are going to have t power 1, which is the same as 2t. Then of course here it is going to be equal to minus 3, because if you differentiate this again, it will simply come down to 3. We are not going to differentiate 2 because it is not actually having our differential component. From here we know at time, for example, at t is equals to 1 second, our acceleration is going to be equal to, we are going to take 2 times our t, which is 1, then minus 3, and this one is going to give us 2 minus 3, which is negative 1, and acceleration is usually measured in meters per second squared. And then at t is equals to 2 seconds, our acceleration is going to be equal to, we take this acceleration function, which is 2t, meaning 2 times t, and our t is 2, we minus 3, and this one is going to give us 4 minus 3, which is going to give us 1 meters per second respectively. Then from there we can go to part C, and part C says, find the maximum or minimum velocity of the particle. And one must know that at the maximum or minimum of anything, the differential function of that particular curve must give you a 0. So we are supposed to find the acceleration, no, we are supposed to find the maximum or minimum velocity. And we know at maximum or minimum velocity, that is part C, at maximum or minimum velocity, the acceleration is usually 0. And we have our acceleration function, and our acceleration function is actually 2t minus t. And this one is going to be equal to 0 because after differentiating the velocity we get the acceleration function, and we know at maximum or minimum velocity acceleration is 0, so we take the acceleration function, we equate to 0. Then from there we know 2t is equal to, this goes to the other side is 3. If you divide by 2 on both sides, this and this goes, and our t is going to be 3 over 2 seconds. But we need what we call velocity. So we are going to take the velocity function, which is t squared minus 3t plus 2, so that we can be able to substitute the value of t and get the maximum or minimum velocity. So we know when t or at t is equals to 3 over 2 seconds, our velocity is going to be equal to 3 over 2, but it is squared, minus 3 times t, which is 3 over 2, plus 2. From here we know 3 squared is 9, and 2 squared is 4. plus, we know 3 times 2 over 3 is going to give us 9 over 2, then of course plus 2. We can rationalize this one into a fraction, then from there we take the LCM, and the LCM of 4, 2 and 1 is 4, then 4 goes to itself once, times 9 we are going to have 9, then plus, we have, this one is actually minus because of this, sorry, then from there 2 goes to 4 2 times, then 2 times 9 will give us minus 18, then plus 2 goes to 4 once, then 1 times 2 will give us 1 goes to 4 times, then 4 times 2 will give us 8. From here we know this is 9 plus 8, which is 17. 17 minus 18, we are going to have negative a quarter, and this is meters per second because velocity is usually measured in meters per second, and that is how that question is done.